Hello again everyone. We're gonna try to determine the velocity of sound in various metals in experiment 11. So we're gonna use this Kund tube to calculate all that. We're gonna try to generate first the vibration, the sound wave basically using this rod and some other mechanism, and we're gonna put this vibration into the tube. The air inside the tube will vibrate accordingly, and the frequency of vibration will be the same for both. We will measure the frequency of the vibration by measuring the frequency of sound in air inside the tube. We're gonna try to measure the wavelength in the air inside the tube, okay, by using sawdust as a visual reference. The vibration will somehow disturb the sawdust inside. We have to put it initially inside. We have to even it out a little bit, make it about 2/3 of the length of the whole thing. And then once we see the vibration, we could determine which is the nodes, which is the antinode inside. And then we can measure the node-to-node distance or antinode to antinode distance directly, which equals to the half the wavelength. A little warning, just keep this horizontal, do not force anything. Okay, if you force it too hard, the glass tube could break very easily. Okay, we have the equipment ready. Again, not too thick, not too thin. Okay, if it's too thick, it's not gonna shake a lot. Okay, and you cannot see it. If it's too thin, you cannot see it either. So make sure you have somewhere in between. If you feel it's not right, you can adjust it. Okay, and one more thing, we're gonna use this towel covered with resin to help the vibration a little bit, make it a little bit more sticky. And you're gonna slide it, do not squeeze it too hard, not too tight. Okay, not too tight, not too loose. You're gonna hear the vibration. If you do it frequently enough, it's gonna oscillate hard, and you can see the pattern. Now we have all the nodes and antinodes visible. We're gonna measure the wavelength by averaging out the whole thing. We're not gonna measure a single loop. We're gonna measure the whole number of loops, as many as we can, and then we're gonna divide by the number of loops to obtain the half lambda, and you can calculate the wavelength. Once we have the wavelength, we could calculate the frequency of both vibrations by calculating the velocity of sound in air. To determine the velocity of sound in air, theoretically, we could use the temperature. You have the temperature of the air in Celsius. We could approximate the velocity of sound in air. And once we have all that, we could calculate the frequency of the vibration in metal. For example, in this aluminum metal rod, you could determine, for example, this point is going to be the node, this point is going to be antinode and antinode. So the whole thing is going to be half the wavelength. Half the wavelength is this, the wavelength is twice of that. And you have frequency multiplied by wavelength to give you the velocity. Actually, there is an extra step. Once you have the velocity of sound in metal, in each metal you're going to use brass, you're going to use aluminum. And once you have that, you could go directly to formula for velocity of sound in metal. You could determine the Young's modulus for each equipment, and then you could compare to the accepted values in the back of the book. Good luck.